Hi, this is Angelo Bobak, the grumpy old IT guy. That's right, you heard me, the grumpy old IT guy. And welcome to my grumpy podcast, Tsql Dml. Okay, now this is the 5th podcast in my beginning TSQL podcast series. TSQL is the query language that comes with Microsoft SQL Server, a high-performance enterprise database and BI platform. Recall that BI stands for Business Intelligence. Now each podcast has a demo or two, or maybe even more, so pay attention, okay guys? And by the way, there'll be 2 other series of podcasts, which I hope you'll find interesting, useful, and helpful. There's the intermediate TSQL podcast coming late summer 2020, and we're going to discuss some intermediate TSQL topics like functions, triggers, and stored procedures. And then there's my advanced TSQL series coming late fall 2020, where we discuss things like transactions and table locks and much more. Now, after taking all 3 series, you'll be able to perform development tasks associated with a TSQL developer, or maybe even a TSQL data architect. Now, here's a little grumpy comment. This podcast will only cover the basics, so please look to my fall 2020 Grumpy University for in-depth courses on these topics. Now, my podcasts are free, but Grumpy University is a subscription-based course. But don't worry, it'll be really, really cheap, just like the grumpy old IT guy. But first, so by now you're probably saying, is this grumpy old IT guy anyway? Well, that would be me. I'm a published author and data architect with over 30 years of experience in BI, data architecture, data warehousing, and data modeling. And before that, I was an electrical engineer. Now, in the last 10 years, I've also participated in several large-scale master data and data quality initiatives. And to support these, I've achieved CIMP certification in master data and data quality. Now, I have to admit, I love the Microsoft BI stack, and I've been using SQL Server for more years I care to mention. Remember SQL Server 2000? Well, I'm dating myself earlier than that. And I can hear you guys grumbling out there going, boy, this guy's really, really old. But anyway, BI stands for Business Intelligence. And lastly, I hold a master's degree in computer science from New York Polytechnic University and a bachelor's degree in electrical engineering, way back when Pratt Institute had an engineering program. And boy, oh boy, you know, those were the days. Both of these schools were in good old Brooklyn, New York, USA, and I had a lot of fun, met a lot of great people, learned a lot, and I have to admit I did a lot of goofing off too. Oh, and by the way, and I'm now, yes, applause, I'm now the founder and president of grumpyolditguy.com. Okay, so get ready to learn the grumpy way. Okay, here's the topics we'll be covering. And just a little comment here, since this is a podcast, we'll just cover the basics, but all the details on these topics will be covered in my Grumpy University this fall. Now, DML stands for Data Manipulation Language. This is one of the sub-languages of TSQL, and it's used to query and maintain data in your databases. So in this podcast, we'll be discussing TSQL Query, Transact SQL Queries, joins, which are a mechanism that allows you to link related tables in a query, the insert row command, the update row command, and also the delete row command. Now, the group by and having clauses that are part of a TSQL query will be covered in podcasts 09. Okay, they deserve a little podcast of their own. Now, in this podcast, we'll take a look at the structure and main components of TSQL in order to prepare you for these concepts and coding examples in my other podcasts. Okay? Let's go and start by taking a look at a query structure. So if I didn't mention it before, but I think I did, DML stands for Data Manipulation Language, and it includes commands to query database tables, insert data into tables, update existing table data, and deleting rows and tables. Now, the basic T-SQL query is composed of parts or sections called clauses and predicates. And the main 6 clauses are, there's the select clause. This is where you identify the columns in the table that you want to retrieve. Then there's the from clause, where you select the actual tables, and if there's more than one table, you need to link them. Then there's the where clause, where you define filters for searches. Then there's the group by clause that allows you to find groupings of data sets in the returned result of a query. Now, what do I mean by data sets? So, for example, if someone asked you in your company, please write me a query that returns sales by calendar, year, month, by customer, and by product, well, that's a grouping of data. And normally you'll have some sort of mathematical function applied to the sales amount, like summing it up. Okay, next is the having clause. Well, the having clause is a filter for the groups of data sets, so you can fine tune exactly what kind of data you want to see. Like, for example, having the sum of sales greater than like $100,000. And lastly, there's the order by clause that lets you sort the results in ascending or descending order, but it also allows you to do much more. So we'll see this in my last podcast. I've dedicated also a podcast to the order by clause. Now, technically, only the select clause is mandatory, as we'll see in our first demo. The other clauses are added as necessary. And then lastly, clauses are composed of one or more parts called predicates, which typically include operators to filter data in the result set generated by the query. Now, we'll use predicates mainly in the where clause, and we'll see what they are. But basically, let's just say that these compare a column to some sort of a value, like where salary is equal or greater than some amount. Now, the basic query usually is made up of a select clause and a from clause. Although under special conditions, you can have a query with only a select clause. And we'll see this in our demo. Now, in the last type, you need to hard code the data you want displayed. And this type of query comes in handy when generating test data. Now, the select clause contains columns, values, or even calculations using functions called aggregate functions, or the regular functions like plus, minus, multiplication, and division. Now, let's take a look at this little example in the clip here. We're selecting the department ID column, an employee ID column, the employee first and last name, and then the full name, which is a concatenation of the first name and the last name. Now, notice that we're aliasing these columns. The actual physical name, for example, of department ID is DEPT_ID, okay? That's what you'll see in the table definition that contains this column. But we're relabeling it as department ID. It's a lot friendlier. And the same goes for the rest of them. And then afterwards, there's the from clause, right? From masterdata.employee. Now, master_data is what's called a schema name. Let's just say that a schema is like a named template, all right? It actually doesn't contain anything, but it has the names of tables that are related. Like, for example, employee is a table, employee address is a table. So those are considered master data. So employee would be the table name. Now, here's a grumpy tip. Give return values a name. So we saw that how we aliased those. All right, and here's another note here. Check out using the plus symbol to concatenate strings. Here's an example of math. It's actually math on text data. We're combining two text strings, if you will, the employee first name and last name, and then we're calling it employee full name. So not only can you do math on numbers, but you can do math on text, although limited, like in this case. And also, you can do mathematics on dates, and we'll see that when we explore the date functions in one of my podcasts. For example, you can calculate in a query the difference between two dates. Okay, let's dive right into a query. There's our little query panel. Well, here's our friend, the SQL Server Management Studio. And we're going to start off with those single select clause queries. So let's make sure we're in a test database. Now, we're not actually going to write any data right now, so it really doesn't matter where we are, but it's always good practice to make sure you're in a appropriate database. So being in the master database as we were before is not a good idea, because the master database, it's one of these system databases that's used by SQL Server, right? There's a whole bunch of system tables and a whole bunch of other stuff, all right? So we don't want to, well, we want to keep away from this database as much as possible. So let's use the test database. And you can create one on your own, by the way, right? Or any test database name that you want. So let's start with the most simple, basic query. Select, oops, I went too far. All right, let's go back up here. I'm really fast on the draw today. Let's select the numbers 1, 2, 3, 4, 5. Okay, and there's the results. 1, 2, 3, 4, 5. Big deal, you might be saying. Well, I can make them a little bit more interesting, but you know, not much. I can cut and paste this query, or copy and paste it. Put these values, oops, tabs lock, tab 1, 2, 3, 4, 5. Okay, I'm having keyboard and mouse troubles today, and that's mainly me. So let's try it again. All right, we've got this blinking going on. All right, here's what I wanted you to see. I want to relabel this output as 1, then as 2, and fast forwarding a little bit. And there it is. I renamed each of those numbers so that when we now execute this query, I've given them column headings. Okay, so real basic stuff, but now you know how to do this. So here's some math now. I'm going to use two built-in functions. I'm going to take the values 1 plus 2 and add them. I'm going to put parentheses around them. Then I'm going to multiply them by 3.0 divided by 2. Then I'm going to convert them to a decimal 5, 2. There's that convert function. All right, so let's just select these values. And there we go. We got the value 4.50. And notice we did not name them, so I can just give them a name as decimal result, for example. And I put in another cursor return. Okay, so let's execute it again. So it's always good practice to give column results a name, all right? And also watch those parentheses. These control the order of execution. For example, I'm going to do something similar. I'm going to select again 1 plus 2. Notice the parentheses. I'm going to multiply it by 3.0 divided by 2 as before. And I'm enclosing that in parentheses. And then I'm going to do the same thing. I'm going to take 1 plus 2 times 3.0 divided by 2. And I'm labeling them first result and second result. Although the values, the numbers I'm using are the same, those parentheses control the order of execution of those mathematical functions, you know, the plus, the multiplication, and the division. So notice that I get two different results. 4.5 is the first result and 3.5 is the second one. So always be aware of those, because you can get into a lot of trouble and come up with incorrect answers. Let's do something a little bit more interesting now. We're going to switch gear. We're going to go to the organization database. All right, let's expand the organization database folder. Okay, there's a whole bunch of tables. I'm going to be looking at the master data.department table, and I'm going to select the department ID, the department name from master data.department. So notice, I've now built two clauses. I've got the from clause and the select clause. So let's go ahead and execute this query. And it returns a small report. I got all those different departments, D01, Human Resources, D02, Payroll, and so on. Now there's a shortcut. You don't have to list all of those columns, all right? You can put an asterisk, and that's a wildcard. It'll return all of the columns in this table. So select asterisk or star from masterdata.department. So now notice that it's included the manager ID. And by the way, I can execute these by highlighting both the queries, and I'm going to get two results there. All right, let's scroll down here. I'm going to do the same thing again with the employee table. Let's expand on the employee table right here, masterdata.employee. I'm going to select all of those columns, and there's my report. Now there's a shortcut, all right? I'm going to put two comments here. And if the table's really big and you really don't want to type all the column names, you can type the keyword select. Then you can just drag the column folder, and whoa, there's all of the columns. Type the word from, and then employee. All right, and then just put a little, I like to always put the go batch terminator. So this will work the same way as the first query. Now, if I highlight these comments here, the code within the comments, and execute it, nothing's going to happen. It'll just say command executed, completed successfully. But if I just highlight the actual query itself, it will execute and give me the results. All right, so just showing you some tips and tricks here on manipulating the query pane and how to write queries and test them. All right, here's a little math, sort of. I'm going to concatenate the employee name. Notice employee name plus a blank space delimited by a single quotes plus employee last name, and I'm going to relabel it as employee full name. Let's execute it. So there's our employee full name. We've just derived our first data. So we don't have employee full name in the actual table itself, but we can derive it. And then we can also create some test data. Here's a little bit more complicated queries. I'm going to introduce something called a union all. There's the select clause. I'm going to select INV underscore ID as invoice number. Now notice the square brackets. I have the square brackets because I have a space between invoice and number. So remember that anytime you introduce a space in names, you need to use square brackets. So I'm going to select the customer ID, the product ID, invoice amount, and invoice date from. I am going to derive data. There's actually no table queried here. I have a series of select statements where I'm deriving data. So I'm going to hard code. This is really fast today, very fast response with my mouse. I'm going to select the string INV underscore 01. Notice again the single quotes, and I'm going to label it INV underscore ID. Then I'm going to select the string CUS underscore 03. That's going to be called CUS underscore ID. And then the string PROD underscore 03 as PROD underscore ID. So I'm generating an artificial invoice number or an identifier, a customer identifier, and a product identifier. Then I'm going to generate an artificial invoice amount. I'm going to use a function called rand, which will generate a random number, and you supply it a seed, like in this case it's RAND2, and I'm going to multiply the results by 100.00, and I'm going to call it inv_amount. Then I'm going to select today's date with the getDate function. There it is all the way to the right, and that'll return today's date with the timestamp. I am going to add minus 30 days to it with the date add function. Notice the parameters I need to pass. The code DD, the value that I want to add to the date, so minus 30 will push me back 30 days, and the getDate function returns the date. So there's a little select actual statement, so I can actually select this all by itself. Let's see, I want to leave out those trailing two parentheses. So notice that I get a date that's 30 days behind. Today's July 2nd, so I've generated a date of June 2nd. I'm then going to convert this to a date, so I'm going to get rid of the timestamp. So if I just select this query by itself, you're going to see one row of an invoice. There's the invoice ID, the customer, the product, the invoice amount that was randomly generated, and the date. Now if I execute this again, notice the invoice amount, $71.36. It's going to actually give me the same one. So sometimes they just keep giving you the same amount. All right, so what I'm going to do is I'm going to take the same query, I'm going to copy and paste it. Notice I have all these queries connected by what's called a union all. So as each query executes, it'll just put all the results together. Now once again, I can just highlight these, and this query should work. Let me try it. So there it is. I've generated 4 invoice records. So now if I take the whole query, I'm going to rename the results, and I'm going to get a nice little report with business-friendly names like invoice number, customer identifier, product identifier, invoice amount, and invoice date. All right, so that's it. That's your introduction to TSQL Queries. So we went from something very, very basic with a query that just had a select clause to then some simple queries against tables. And now we've basically generated 4 artificial rows for an invoice table. Okay, topic 2. Our next topic is joins, which are required when 2 or more tables are used in a query. Now, quite simply, the join clause identifies columns, common columns, I should say, in both tables that are used to implement a link between the pair. Now, for example, in the clip, we're going to be joining the department table to the employee table. Now, the business rule for this example is that a department may have 0, 1, or more employees. And to implement this rule, we need to include the department ID column in both tables. Hence the code snippet from master_data.department D, that's the alias for the table, inner join masterdata.employee, and E is the alias for the employee table, on d.department ID equals e.department ID. That's how you establish that relationship. And again, notice the use of aliases, D for department and E for employee. And we're going to use those aliases, by the way, in the select clause, as can be seen, so that we can identify, or I should say the query engine can identify where those columns come from, in case you have columns with the same name in more than one table. So let's look at the other types of joins. Okay, let's take a look at some diagrams called Venn diagrams. They're used to show the relationships between sets of data. Our most common join is the inner join. This join is used when we want to see data common to 2 table pairs. Now, by common, we mean that there are common columns called keys that can be used to link to tables in order to retrieve data that is related. Now the left join or left outer join works the same as the inner join, except that not only data common to both tables is returned, but also data that is unique to the left table in the join. Now the right join or right outer join also works the same as the inner join, except that data common to both tables is returned, and also data that is unique to the right table in the join. Now for these joins, columns that are common to both table pairs must exist. For example, if we join a customer table to an order table, we would expect a column like customer ID to be present in both tables so we can establish the required relationship. And lastly, the cross join is the odd duck of the joins. No common columns are required. And we'll see how this join comes in handy in cases where we need to generate test data. All right, let's go to our second demo, joins. And here's some grumpy wisdom. You need to walk before you can run. Okay, here comes SQL Server Management Studio. Let's scroll down carefully to joins. Now I'm going to, well, I'm already in the organization database. Okay, you know, by using this use organization, you can switch to the right database. So let's say I'm in the customer database and I execute use organization, and there I am. So we're going to start off with a very simple join. I'm going to write a query that basically joins the department table to the employee table. I'm going to select from the department table the department ID, the department name, and from the employee table the employee ID, employee first name, and employee last name. Notice that the physical names are slightly different, like DEPT underscore ID for department ID. There's the department table, and there's the master data employee table right below it in Object Explorer. There's my from clause, master data.department with an alias of D, and then join master data.employee E, that's the second alias, on D.department ID and E.department ID. So let's execute this query. And there it is, lightning fast for some reason. There's the results, a nice little report. Okay, nothing fancy. Now, this query, if I rewrite it slightly, if I select E.star from masterdata.department ID inner join masterdata.employee E on D.department ID equals E.department ID, it'll basically work the same way. Well, basically, it won't, because I'm just selecting columns for me. Let me copy the select clause, replace the select clause here, and basically I'm going to get the same results with the inner join versus the join. And to further prove that, let me copy this second query. I'm going to create a new query pane, and some of you have seen this who've seen my podcast. Just right-click on the tab, new vertical tab group. Let's paste the query and execute it. And then I'll execute the top query here. So, okay, the purpose of this exercise is just to show you that inner join and join are basically the same thing, right? So if we compare the output here, it's the same. All right, so you can use inner join or just join if you don't like to type. All right, that was the inner join. Let's do a left outer join. Now, the left outer join, what it'll do, it'll return rows from both tables that are joined by the on clause there, the on D.department equals E.department ID. But it'll also enter rows from the left table. In this case, the left table is the department ID. Let me put a comment here and just call this the left table. And I'm going to put a comment here and call it the right table, so it's a little clearer. All right, so let's execute this. And basically you see from the output that I have a department called D005 called marketing. And notice the employee ID, employee full name, and employee last name columns, they're empty. So that's how the left outer join works. Now the right outer join works basically the same way, except this time you're going to see any employees in the employee table that have not been assigned to a department. Okay, so I'm selecting the same columns. Let me tidy this up a little bit. I actually like this format because it's legible, and then if you want to add aliases to these column names, it just works out better. So there it is. Select all those same columns from master data.department D, and then I'm going to have a right outer join master data.employee on that department ID column, and this time I'm going to order them by employee ID descending. Let's execute this query, and there you see you have employees 16, 17, and 18, right? Mary Green, Barry Smith, and John Barry that are not assigned to a department. Okay, so this is a good way to debug data. And by the way, needless to say, all of these names that I'm using are made up in my little grumpy head here, okay? They do not represent anyone living or dead, as they used to say in the old movies. Now here comes a cross join. All right, the cross join is interesting because you don't have a on column equals column clause in your query. So what the cross join does is create something called a Cartesian product. What does that mean? Well, if in the left table you have 10 rows and the right table you have 1,000 rows, your output will be 10,000 rows. And this is good to create fictitious data. All right, so I have, let me see here. I have a master data.course, but I don't have a course backup table. Okay, so I want to create a backup of my course table. So how do I do that? Well, first, let's select star from my course table. Let's hope I have data in here. So it's taking a little bit of time, and I have 4 courses. Okay, perfect. So what I'm going to do is on the fly, I'm going to use a query. I'm going to do some copying and pasting. All right, and I'm going to slip in here an into keyword. I'm going to cut and paste master data course. And I'm going to change the name to underscore BU for backup. Okay. So now I'm going to execute this. And I've now got a backup table for my course table in case I mess anything up. So I want to insert into master data.course, select course ID course name from master data.course BU. Okay, this is how I recover, right? So if I truncate this data now, okay, this data is gone in the course table. Oops. But I can use this query here. Insert into, it's an insert statement, insert into master data.course, select course ID, course name from master data.course BU. All right, 4 rows affected. Do I have all my information? Yes, I do. It's all in there. So now I'm going to, let me see what we got. What do we got here? I'm going to create a table on the fly called employee underscore course by basically taking the Cartesian product of each employee and cross-joining it to the course table. All right, so first I'm going to execute this query to see what I get. So basically the results I get is that each employee is going to be assigned to each and every course that's out there. All right, so I get 72 rows. Okay, so now I'm going to create this master data.employee underscore course table on the fly. I'm going to uncomment that into part into master data.employee course. I'm going to execute this query again. There's already an object named course in employee course in the database. Absolutely. So what do I need to do here when I'm testing out? I need to say something like drop table if exists. I'm going to drag that master data.employee course there. All right, I'm going to drop it, refresh my table folder, and I'm going to run that query again. So now it's been recreated. Now you might be saying, well, why are you like dropping tables that already exist? Well, when you download these scripts from my grumpyolditguy.com site, all right, you'll be messing around with it. So you want to have all these statements like the drop tables when you're experimenting available. That's all. And it also illustrates how to, drop these tables, recreate them, etc., etc. Now, if I do a select star from master data.employee course and I order by employee ID and course ID, you'll see what I mean. There's employee E01, and that person's been assigned to all 4 courses. The same for E02 onwards and onwards, okay? So that's the end of our topic 2 joins. Okay, topic 03, insert rows. Now inserting rows is easy. Just use the insert into command followed by the table's name and then the values keyword and a list of the data that you want inserted. So for example, insert into test table values string 1, string 2, string 3. Notice that they're delimited by the single quotes. Then there's a value 10.2 and finally 5. So if we look at the layout of the test table, the create table command there, you see text 1, text 2, text 3, varchar 256. The first 2 are not null. Text 3 is null. Then there's the decimal value, so it's a decimal 10, comma 2, and it's required, not null. And finally, the integer value, which is null. Now you do need to include 1 data item per column in the tables, unless you specify the columns before the values operator delimited by parentheses. Okay, so in this case, I'm inserting every single column in the test table. For example, insert into test a table. Now I have 4 columns, the 4 mandatory columns, all right, that are that need to be supplied. Text 1, text 2, and decimal value. 3 mandatory columns, all right? So there's a variation of that insert statement. Now the remaining columns need to be declared with a default value if they're not defined as not null. Since they're defined as not null, in other words, the decimal value is not null, we don't have to worry about it. I'm sorry, the text 3 is null, integer value is null, so we don't worry about it, all right? And by the way, numbers need no parentheses. Okay, each value must be separated by a comma though. So let's go ahead to our next demo. Here's a lot of demos in this podcast. And let's see how to insert rows. Okay, here comes SQL Server Management Studio. And we're going to start off by creating a test table with different columns with different data types. So we're going to use the test database. And let's take a look at the test database. If we have any tables in there, we don't. So we're going to create this table called test underscore table. So notice the first 4 columns, they're all varchar 256. Text 1, 2, 3, 4. They're going to contain some text strings. And the first 2 are not null. The third one is null. And the fourth one is not null, but with a default value of not defined. You can see if you use that keyword default and then some sort of a string, that string will be inserted if you don't supply a value. Then there's a decimal underscore value column. Its data type is decimal 10, 2. It's also not null. And then there's an integer value, which is an integer value, and it's null. So let's create this table. Okay, let's refresh our tables folder. There it is. All the columns are there, so we're in good shape so far. So let's start off by inserting one column into this table. One row into this table. We'll use the insert statement. Notice there the keywords insert into, test underscore table, and then the keyword values. And we're going to pass 3 strings, string 1, string 2, string 3. Notice that they're delimited by the single quotes. Then the keyword default, in other words, we're not supplying a value. And then 10.2.5. So let's go ahead and insert this row. Let's see what we have. We're going to do a simple query, select star from test table. So there it is, all the data was inserted, and notice text 4, it has the string not defined. So that's a good way of doing things. Now let's insert another row, but this time we're going to specify the columns that we want to update. So we're going to insert columns text 1, text 2, and then decimal value. These 3 are not null. And we're not going to even mention text 4, which I believe is our column that has the default values. That's right. So let's see what happens when we insert data this way. Again, we're defining the columns there between parentheses that we want to insert, and we're only supplying 3 values in the values portion of the insert statement. So it looks like it worked. Let's select all the rows. There's only 2 really. So notice that second row, string 1, string 2, no value for text 3. There's that not a defined string for text 4. And then a decimal value 10.20, which is required. And finally, there's a null integer value. So now you see the different permutations of how to insert data into tables and how to include, or I should say, under what conditions you can include or not include data for the columns. All right, let's just clean this up by dropping the table. And now we're going to switch gears to the organization database. Okay, we are going to create a few tables first in a schema. All right, now I do believe I have the schema already created. And if I go back up here, I do have the catalog table. Let me refresh this. There's the catalog table in the sales schema and the purchase table also in the sales schema. So I'm not going to actually drop these tables and recreate them. I'll just describe them to you. The catalog table has only 3 columns. All right, the product ID, varchar 6 not null, a product name, varchar 32, and a retail price, which is a decimal 10, 2. Now this is supposed to basically represent a catalog of products that a company or a department within a company would buy, like, stationery, things like that. So I do have a little typo here. This should be a unique product. I am going to truncate this table first, just in case there's any rows in it. Truncate table, sales catalog. I like to put my little go statement there. And I'm going to insert these 5 products. Okay, insert into sales.catalog values. P01 printer paper at $5, P02 ballpoint pens at 15, and so on and so forth, right? So the typical stationery products that a department would buy. So let me just insert them. Let me highlight that, truncate again. Insert the rows. It's going to be 5 rows. Now notice it took a little time, it took 4 seconds. That's because the SQL Express product, all right, is it's a scaled down version of SQL Server, so the performance isn't going to be the same as SQL Server. Let's select star from the catalog, right? Very simple query. And there they are, so everything is loaded. So what am I going to do now? I'm going to create a table called purchases, which by the way I do have. So let's take a look at it. There's a column called purchase key, it's an integer, and then it's an identity column. So what that means is that you don't have to supply data when you insert rows for this column. The value will be automatically generated. So in this key there'll be integer values, and for the first row the value will have 1. For the second row the value will have 2, and so on and so forth. And I put them there for one specific reason, because I'm going to use it to generate unique invoice IDs. But let's look at the rest of this table. There's a department ID, varchar 6 not null, invoice ID, varchar 32 not null, and a product ID, varchar 7 not null, and a purchase date not null. So all the columns in here are not null. Then there's a quantity, and then the price, and then the total price, which is the product of the quantity times price. Okay, so let's drop and recreate this table. All right, let's expand this purchases table. There's all our columns, everything looks good. So what I'm going to need to do now is to create some purchase data. And I'm going to use those famous cross joins that we discussed. So right off the bat, this query looks fairly complicated, but if you break it down to its individual pieces, it's really not. We're going to insert into the sales purchases, and then we've generated a select query. We're going to select the department ID. We're going to automatically, I'll generate like a random invoice number. We're going to take the string inv dash, then we're going to concatenate it to the calendar date. Now that won't give us a unique invoice number, but I'm going to show you how we're going to make it unique. Then I'm going to get the product ID from the catalog table, the calendar date again from the calendar table. Then I'm going to generate a quantity. I'm just going to pull the most value of the department ID column, right? They're all numbers, and I'm going to convert them to a small integer. Then I'm going to generate a price. I'm going to take the retail price from the catalog table. I'm going to multiply it again by that conversion to a small integer of the rightmost character of department ID, which is going to be a number. And finally, I'm going to generate the total price by taking again the rightmost character of the department ID, converting it to a small integer, and then I'm going to multiply it by the catalog price, right? The retail price, I should say. And the tables that I'm going to use are masterdata.department. Notice the alias D. Then I'm going to cross-join that to masterdata.calendar. That alias is CAL. And then I'm going to cross-join it a last time to the sales.catalog table. And that alias is CAT. So notice in the select clause there, I'm using all the aliases. I'm prefixing them to the columns. And finally, I'm going to filter this query by pulling the day. I'm using a calendar function called day. I pass it the calendar date, and I'm going to say where day of calendar date is in 28, 30, and 31. So what I'm trying to do here is just simulate that each department reorders stationery on one of those days, all right? So now if I insert data into this table, shouldn't take too long, but it's going to generate a whole bunch of rows because I'm using cross joins. So as you can see, it generated 8,250 rows. Let's take a look at what it looks like. All right, there's the data, but notice the invoice ID, they seem to be all the same, and they all only really change when the date changes, so that's not good. Now there's a way that you can check for duplicates. You write a query here. I have a select invoice ID as duplicate invoices. Then I'm using the count star function. It's going to give me the count of duplicate invoices. I'm labeling that num_dups num dupes from the sales purchase table. I need to use the group by now. I'm going to introduce the group by in the end of the series for these podcasts, but I'm going to sneak it in here. I need to introduce the group by because I'm using that count function. And then I'm going to filter the group by what's returned. I'm going to have a having count star greater than 1. So in other words, if the dupes are greater than 1, if the values are greater than 1, it means I have duplicates. So let's execute this query. So there you see, I have 330 rows, and I have invoices that are duplicated 25 times. So I'm going to need to correct this. I'm going to update that invoice ID. I'm going to do an update sales.purchases. I'm going to set the invoice ID equals to itself, plus I'm going to concatenate it to a dash, plus I'm going to convert to a varchar the purchase key from the purchases table. Let me show you how that key got generated. I'm going to select the top 1,000 rows from the purchases table. So notice the purchase key, it's incremental. I got values 1, 2, 3, so on and so forth. So these are all unique values. So if I now concatenate them to the invoice ID, I should get all unique invoice IDs. So let me execute this update statement. I'm going to now do that same query again to check for duplicates. Good, I have no duplicates. All right, so let's select star from sales.purchases and we'll order it by purchase date. And look at those invoice IDs. They seem to be all nice and long and unique, right? So this whole exercise not only showed you how to insert data into tables, but how to generate random values and derive values. So this is a good example of generating test data. Now let's just do another insert. We'll truncate the master data.employee table, and we're going to insert, how many rows here? We're going to insert about 16, 17, 18 rows, I believe. Let me just go scoot up there again. Again, that fast scrolling response. Got a fast laptop here. So notice how I'm inserting the data. Each row that I'm inserting is set, with a set of parentheses. And within the set of parentheses, I'm putting in the data. So in this case, the department, for example, first row is D001, then the employee E001, and then the first and last name, John and Smith. And I repeat this across for all, let's say, I think it's, as I said, 18 rows. And by the way, again, all these names are fictitious. I'm just making them up. So I'm going to truncate the table in case there's data in it so I don't introduce duplicates. And I've just inserted 18 rows. So let's take a look at this employee table. Select the top 1,000 rows. There's only 18. So there it is. So that's how you insert data. And we did a couple of different things. So that's it. So let's get back and look at our next topic, which will be how to update rows, which we kind of snuck it in here. Well, congratulations. You made it to topic 4. So let's discuss updating rows a little bit more. Now, updating values in a table is accomplished with the update command, right? We saw that already. Simply supply the table name followed by the set keyword and then a list of column value pairs for each column you want to update. So for example, we're looking at update masterdata.course, set course name equals to TSQL programming. Notice how the text string is surrounded by the single quotes. And then we've got a filter, the where clause, where course ID equals to C0119. All right. Now the where clause is optional, but it can be used to define a filter that identifies when to update a column, specifically for which rows or values in a column. And then the next examples shows you how to correct a spelling mistake by using a where clause with a like predicate. Right? Update master data course, set course name equals bookkeeping for beginners, where the course name is like the string BOOKKING, right? Clearly booking misspelled. And then there's a percent symbol on each side of the string. That's a wildcard. So just look for any string that basically has those letters in it, BOOKKING. Right, so that's really all that there is to it, although you can add very complex filters to really narrow down the columns and the rows you want to update. All right, without further ado, let's just go do another quick demo on updating rows. Okay, here comes SQL Server Management Studio. Quick check, are we in the correct database? Yes, we are. And let's take a look. We're going to work on the course table. I think we have some courses in there. We've got 4 courses, but what we're going to do is we're going to reload these courses, and we're going to introduce some bad data. Okay, so let's truncate this course table. And let's insert 4 courses again, but notice the 4th course, C004. Booking for beginners, actually booking is spelled BOOKKING, so it's a on-purpose error. Okay, so let's just insert those rows. Actually, let's cut and paste this little simple select query here. And there it is. There's that little error. Okay, so it doesn't look too good. Right, and we're also going to insert another row here. Again, I've got this real fast scroll bar here. I don't know if that happens to you guys, but it gets annoying. But anyway, I digress. So we're going to insert another course, C0119, and TSQL programming, no space between TSQL and programming. So I'll call it a data quality issue. So let's insert the row. Let's query it again. There it is. All right, so we need to do some fixing. All right, so the first thing we need to do is to make a backup. Okay, we do already have a backup table, I believe, for the courses. Let me refresh here so I can see them. Yes, I do have a backup table. Let's take a look at the columns in it, because sometimes I created it without the backup date. So let me just drop this table and recreate it with the select into. This time I'm going to add a column in my select clause. I'm going to select star or asterisk, comma, get date as backup date into masterdata.course_bu from masterdata.course. Now, of course, the query, the insert statement as is a syntax error because I have the insert into up here. But I'm just going to highlight this part of it without that top insert into, and it should work. And sure does. So let's see, what do I have? So there's my backup table with a nice timestamp when I backed it up. All right, so now let's update masterdata.course. Let's set the course name equals to TSQL space programming space 3, where course ID equals C0119. So notice there in the output that C0119, that course that has the data quality issue. So let's do this update, simple update. Let's now select the course, and now that little problem has been fixed. All right, what do we need to do here? I'm going to do 2 column updates as an example. So we've got that row there, C004. that has that misspelled word for booking. It has B-O-K-K-I-N-G in the beginning. So I'm going to update the masterdata.course. I'm going to set the course name equals to bookkeeping for beginners. And I'm going to give it a new course ID equals to C004.1, where course name like the misspelled word. Again, notice the percent signs that are used for wildcards. So let's do the update. And basically those percent symbols say, the first one says ignore anything that comes before the misspelled booking word. And the last percent sign says ignore anything that comes after. So, okay, let me easy scroll down here. And let's see if we fixed everything. We sure did. Okay, so everything looks pretty good. What can I do? I can make another backup. Why do I want to do that? Well, I'm going to comment this out. I'm going to back up again. And I'm going to select all the rows. I should have 10 rows now. So now what you see is I have two sets of backup with different dates. So when you use this technique, you might end up having 4 or 5 different sets of backups. So you can go back to whichever date you felt was the correct data in case you need to go back to a prior version. Okay, so that's it for updating rows. Okay, now we're going to look at deleting rows. Okay, topic 05, deleting rows. Now, deleting rows from a table is accomplished with the delete from table command. Now, as can be seen, the optional where clause limits which rows to delete. Delete from masterdata.course, where course ID equals to C004. So that's pretty simple. Or delete from masterdata.course, where course name like BOOK and then a wildcard. This is a little more dangerous because if you have several rows that begin where the course name begins with book, well, you might you're definitely going to delete all of them. Is that what you wanted to do? You know, you have to be very careful. And then there's the last one. If there's no where clause, all rows will be deleted from the table. So watch out. And there it is, delete from masterdata.course. Yep, there's that grumpy alert, man. If there's no where clause, just be careful. All right, let's proceed to a demo where we're going to delete rows. Here we are back in SQL Server Management Studio. We are in the organization database, so we're fine. So take a look at this. We're going to work with the masterdata.course table. So we've got 5 rows, I should say. So let's try our first delete statement. Delete from masterdata.course, where course ID equals to C004. Now look at the data. Is this going to work? Well, let's try it out. 0 rows affected. Why? Well, because there's no course ID of C004. There's a course ID of C004.1 though. So if we execute this second query, delete from masterdata.course, where course ID like C004 %, let's see what happens. 1 row affected, and that course is gone. All right. Well, I'm sorry. I wanted to highlight the select statement. So that course is gone. So now if we try to delete from masterdata.course, where course ID equals to C004.1, that also is not going to work because we deleted it with the wildcard statement. All right, let's see what else do we have to do here. All right. Well, again, real fast scrolling here. Let's look at our course data. Let's execute this query. We have 2 courses there that begin with the name accounting, the word accounting. So if we delete from master data course, where course name like accounting, all right, let's select the query, see what happens. All right, we deleted both of those rows. Is that what we wanted to do? All right, so there's a double oops. Now we're just going to say delete from master data course. Let's take a look at what we did. We deleted everything. All right. Fortunately, we do have a backup. All right, so we need to restore from the backup. All right, let me show you what we have. Just a quick reminder what we have in the backup table. Let's do a quick copy and paste. All right, I'm just going to say select star from master data master data dot course backup. So we've got 10 rows, we've got 2 sets of data. So we need to pick one. Well, I want to pick the one that has all of the data quality issues fixed. All right, I do have code here that fixes the data if I don't have a good set of data. But let's look at this query first. So if I select max backup date from master data.course, I'm going to get that 15.21.35 timestamp. All right, there it is, 15.21.35 timestamp. On the other hand, let me just do a quick copy and paste here. Same query. This time I'm going to say min. M-I-N. So now if I pick the min, I'm going to get the earlier timestamp, and those are the backed up rows that have the errors. So you know what? Let's do a restore from the bad data set. All right, so it's executing, and I got 5 rows. Let's see what we got. All right, select star from master data.course. All right, all those little data quality errors are back. No problem, we've got the code. We can apply the fixes. Update master data.course. Set course ID equals to C005, where course name, and also course name, I'm sorry, let me do that again. Update master data.course. Set course ID equals to C005. Course name is equal to TSQL Programming 3, and where course ID equals to C009. So in other words, I don't want that C009 anymore, right? I want to change it to C005, and I want the course name to be correctly spelled with a space. So let's do that update. And then I'm going to do the update of the booking word error, and I believe bookkeeping is just one word. So I'm going to update the master data table again, master data.course table therefore, and I'm going to set course name equals to bookkeeping for beginners, where course name is like that BOKKING string. Okay, so 1 row affected. Select star from course. And that's it. So now I've showed you how to delete rows and how to restore them from a backup set. Okay, we're back. Topic 06, truncate table. Now I did lie to you. I think I said that topic 5, the delete rows, was going to be the last demo, but we actually have one more. Now the truncate command will delete all rows in a table, and once they're gone, well, they're gone. Okay, so use this with extreme caution. Now the prior command we looked at, the delete rows command, or delete from table, is logged. So under some conditions, it's possible to retrieve the values back into the table where the rows were deleted. Now, so if you have a table with 10 million rows and wish to empty it, the truncate command is the way to go, but make sure you really, really want to empty the table. Okay, because once you issue the truncate, it's gone. You can't recover it. unless you have a backup, of course. All right, so here comes our very last demo, truncate table. Here comes SQL Server Management Studio. Let's scroll down carefully. You've seen the luck I've had with scrolling today. All right, let's go to the test table. The test database. All right, we executed that use test. Now, let me refresh the tables folder. And let's expand it. And I have no table, so I don't have to drop the test table. So I'm going to recreate it. We looked at it before, so I'm not going to go into any detail explaining the table. It's got the same text columns and decimal and integer columns. So the table's there. Refresh, all right. And let's just insert those strings as we did before so we can get some data in there. All right, we'll insert those strings. And we'll insert another row. Now I just put it separate just to show you the different, coding styles, if you will. I prefer to see things vertically, like those columns, text 1, text 2, because to me it's clear, all right, when you do it this way. So let's just insert this last row. Let's take a look at what we have. All right, here we go. So we now set the stage. I'm going to introduce an advanced topic called transactions. And I'm going to have a podcast on transactions. I think that's in my intermediate podcast series that comes after this introductory series. But basically, transactions are like, they call them units of work. So they're used to guarantee the consistency of a database. So basically, you put code between a begin transaction and end transaction, and it's guaranteed to either complete, or if it fails, it'll do what's called a rollback, and the database will be in a consistent state prior to when any of the modifications were being done in the transaction. If there's no errors and the transaction finishes to completion, then you have the new or modified or deleted data. So what I'm going to do here is I'm going to begin the transaction. I can also execute these commands one by one, by the way. So I'm going to begin a transaction. I'm now going to delete from test table where integer value is null. Okay, so before I do that, let's execute the query. All right, so I'm going to basically delete that last row. All right, now I'm going to select from the table. Last row's gone, right? Actually, we've got 2 rows are gone. But now, instead of committing the transaction, notice I have it commented out, I'm going to do a rollback transaction. All right, now I'm going to select star from the test table. Okay, so that row is back. All right. So that's what I meant before. I think I said that under certain conditions, when you delete data from a table, you can recover it. Well, this is the scenario. If you're in a begin transaction, commit transaction situation, or a rollback transaction situation, you can do it. But the topic of this section of the podcast is truncate table. Watch what happens when I truncate the table. Okay, all the data's gone. There's no data. All right, so there's nothing that you can do about it. All right, so we'll drop table, test table. What do we got here? All right, use organization, drop table if exists, master data course.backup, and then we're going to back it up again. So this time, let's get rid of that backup table. Okay, rebuild it with just the latest data. Oh, what did I neglect to do, guys? Use organization. Now I'm going to drop the table, the backup table. All right. Now I'm going to rebuild it by that select into that we looked at before. I'm going to select into a new master data course backup table. I'm also going to put that get data as a backup date. All right, so I should have data in this backup table again. Let's right click on it, select the top 1000 rows. So I got 5 rows of good data. So now if I go ahead and truncate the table, the actual master data course table, and try to look at the data, okay, it's empty. But fortunately, I have a backup. So I'm going to execute that code we saw before, insert into masterdata.course, select course ID and course name, but no backup date, from masterdata.course.bu, where backup date equals, and then I have this little nested query. Now in this case I only have one backup date, so I don't even need to execute the whole query. I can just execute this part of the query, and I will have recovered all my information for the course table. And there it is. So we recovered. All right, so that's the end of our final demo. So, let's recap what we did in this last demo. We showed you I showed you the two scenarios under which you can delete data from a table. The prior demo, we deleted it with the delete command, and in this demo we used the truncate. And we saw the dangers of deleting and the importance of backup. And we also took a peek at transactions, okay, just a little peek to whet your appetite, so you'll go see my intermediate podcast on transactions. Okay, let's just wrap this podcast up. Okay, that's it. Let's wrap things up, summarize what we learned. Okay, we learned that T-SQL contains the following parts called clauses, a T-SQL query that is. All right, there's a select clause, a from clause, a where clause, join clauses that help us link up queries that have more than one table. Then there's the group by and having clause, which will be covered in podcast 09, as you've seen here in the little grumpy alert that came by. And then the order by clause. And you also learn the basics of managing data with these commands, the insert command, the update command, the delete row command, and truncate table command. So you should now be able to download a free version of SQL Server and start some basic coding exercises based on these podcasts. And yes, there's a podcast that will show you how to download and install the free developers version of SQL Server 2019. Well, let's discuss my tool podcasts. But first, I just want to say thank you for watching this podcast, and I hope you enjoyed it. And I hope you learned the basics of, doing T-SQL queries. Now, here's a list of my podcasts for the category of SQL Server tools. There's podcast T01, Installing SQL Server 2019. That's the free developers edition, so it'll show you how to download it and then install it and configure it. Then there's podcast T02, Installing SSMS, SQL Server Management Studio. All right, that's what we've been using all along in these podcasts, SSMS. Then there's podcast T03, Installing Data Tools 2019. Now this will install data tools in Visual Studio. Okay, this will enable Visual Studio to basically to create and manage and support SQL Server based projects. Now if you don't have Visual Studio, well, podcast T04 is for you. It'll show you how to download and install Visual Studio 2019 Community. That's the free version. And then podcast T05 is Installing Reporting Services. Okay, Reporting Services is part of the Microsoft SQL Server BI stack, and it's a really nice and powerful web-based architecture that allows you to create and deliver web-based reports to your users. Podcast T06 is Installing Report Builder. That's the tool that you're going to use to create the reports, the web-based reports, and then publish them to reporting services. So you definitely want to take these 2 podcasts. And finally, podcast T07, installing Power BI. Now, Power BI is a very advanced, I'll call it an analytical tool, a GUI that will let you create sophisticated scorecards and dashboards based on SQL Server data and other data like spreadsheets and data files. So this is definitely another value-added component of the Microsoft BI stack. I mean, any company that's pursuing a strategy of data warehousing and data mining should definitely look into these products from Microsoft. And that's just my humble opinion. So after installing these tools, you'll be able to do the demos in all of my TSQL podcasts, by the way. So let's finally wrap things up and see what other podcasts are in this introductory TSQL series. Okay, that's it. I hope you enjoyed this podcast, and I hope you learned what Tsql Dml is. Now here's a list of my available podcasts for the category of TSQL Basics. All right, for those of you who've already taken these first 5 podcasts, thanks, be patient. But for those of you who might have just joined us on this TSQL journey, I have podcast 01, Navigating SSMS. That's the tool that we've been using along in all these podcasts, right? That's the tool that's going to be used to develop your queries and create and manage database objects. Then podcast 2, 3, and 4 will take you to creating databases, tables, and views. Podcast 05, this podcast is Tsql Dml, all right? Data manipulation language. So if you've gotten this far, you know what that is. And then finally, podcast 6 and 7, string functions and date functions. You're going to use these built-in functions in your queries to manipulate string data and date data. So very important component in your TSQL tools chest. So be sure you take them. And by the way, podcast 06, of course, is next. And then podcast 08, the order by clause, will show you how to sort the data returned by a TSQL query. And podcast 09 will show you how to group the results into sets in your query. Now, what do I mean by grouping results into sets? So if a user comes up to you and says, hey, I need a report of sales by calendar, date, product subcategory, and customer, right? That's a set of data. That's a grouping. So the group by clause will show you how to set that up. All right. Oh, and here's finally a grumpy reminder. Yes, applause and a shameless advertising alert. Be on the lookout this fall for my Grumpy University at grumpyolditguy.com for a buffet of TSQL courses to enhance your skills. So see you in podcast 6, String Functions.